Doing a furnace maintenance on a Amana Distinctions furnace. It's a high efficiency. Okay, so we've got his bottom door off here, and what we're looking for in here is we're going to observe the filter condition. We're also looking for any debris, dust, dirt, that sort of stuff. Now, if we go over to this side here, I don't know if I can get a good shot of it, but this in here is his blower wheel. And those blower wheels are notorious for picking up pet hair. If a house is being smoked in, it gets a lot of debris on those fins, in turn taking our airflow away. So on a maintenance, they should be peeking in here, making sure your blower wheel's good. This one is good. Now I'm gonna clear out all his condensation lines. There's one coming here. I'm gonna undo it at the fitting. I'm gonna blow air in that side and make sure that's not plugged up. I'm also gonna blow air in this hose into this fitting, making sure again that's not plugged up. Now with this particular unit, we do have a drain hose on the right side here. That's for our venting system. I want to remove that clamp, clear the hose, clear the fitting. I'm also gonna do the same with this hose coming off our collector box. This pipe here, usually these never plug. The nice 3/4 inch line, those are known to plug up. It's the 1/2 inch ones. So I'm going to remove the tubes. I'll get my customer to hold the phone once I start, and we'll record the process of that as well. Right at the very top, we're going to take a burner brush to his burners. We want to scrub off the carbon buildup, because if we get too much carbon building up in here, we could have high CO reading in the exhaust. So we just scrub that up like that. I also like to go across the orifice part here, just in case we get spider webs. Spider webs are notorious for making high CO. Okay, so now I'm gonna go dip down in here. I gotta take this flame sensor out. So these are a little finicky to get out, but I've done many of them. So I'm just gonna be patient. Undo the screw a little bit at a time till I get this rod to drop out of its spot. And then once I get it out of here, I'll show you the signs of what happens to these as they sit in the path of the flame there. And I appreciate my customer here taking the time out of his day to film me. But we're just giving awareness on a furnace maintenance, what you guys should be expecting to see on our visits. And it's not just the old vacuum clean and make some noise, bang some stuff around. We're doing safety checks as well as performance checks on his unit. Okay, so this sensor's almost out. Couple more turns and I should have it drop. There it is. So you got to be careful you don't drop that screw in behind everything, because you'll never get it back. So I'm going to place that there. Here's his flame rod. So soot buildup, carbon builds up on these. If they get very dark and dirty, they're going to prevent furnace from heating up. And that's because it failed the safety. The flame sensor didn't get satisfied, and turn the gas valve won't stay lit or stay open. So fine steel oil's the go-to for this. Don't ever use sandpaper on these rods. Sandpaper scratches the rod and it'll collect the carbon 3 times as quick. Some out there where the guys use sandpaper were getting flame rod failure within a month of operating that furnace. Alright, so our flame sensor's clean. I'm gonna put it back in its spot. The easiest way to do these ones is put the sensor back in first, and then put your screw back in. So I just line this up like so, and then I'm just gonna get my little screw, and it's a little tricky getting this back in, but like I said, I've done many of them, so I kind of know where I have to go to get that back easy. Okay. Alright, so I've got it started. Now I've just got to tighten that bolt up, or the screw, just to tighten the rod in place. So when I get this done, I'm going to continue on with those condensate hoses, I want to clear all the hoses out of any moisture, debris that could be in there. It just takes a bit of moisture in these hoses to prevent the switch from closing. In turn, we will see the furnace fail in operating mode. So first things first, I'm going to remove this tube here. And I have some adapter hoses that I'm going to hook up to in order to confirm that these lines are cleared. So first one will be right here. So that's clear. I will not blow any air in that hose because it is hooked up to our pressure switch and I do not want to damage the switch. I'm going to remove this other little tube. I've got a little probe here, so I'll blow some air in this hose. Again, I'm not going to undo it from the end and blow this way because I can damage our pressure switch if I blow air in there. Next thing, I'm going to clear the two thicker condensate hoses. So there's one on the right, that's for our venting system. And to remove these, this clamp's not really on there tight, we just slide it down, pull the hose off. I'm going to get my little adapter hose. I just want to blow a bit of air in here to make sure that this line isn't plugged. So that one is clear. Now I'm going to take my other adapter hose and I'm going to blow air just the way I did in that hose, but in this actual fitting. These are going to plug up. It's usually at the fitting where they'll plug up. Alright, so I confirm both of those hoses are clear, the fitting itself and the hose going up to the, or down to the trap. So I will put this clamp back on in place so that we don't get no water leaking. Alright, and then I'm just going to remove this clamp on the right side corner, bottom of this collector box. And exact same thing, I want to blow some air in this little tiny hose. Make sure it's cleared out. Okay, so that one's clear, and I just want to put this other hose on that fitting and make sure it's not plugged up as well. Now this furnace, it's only 1 year old, and a lot of people, these customers, they think, oh geez, I got new equipment, I don't need maintenance on it, it's brand new, I've got warranty in case something happens. Don't go by that. You definitely want to get these checked out. So I'm going to hook up my manometer. I want to check pressure here. The measurement that we're going to be dealing in is inches of water column. And with this particular furnace, I'm aiming for 3.5 inches. So I'll turn my manometer on. This is also a combustion analyzer, which lets me check carbon monoxide in the exhaust as well as in the house. So we'll let that start up. Just tear that. So we're at 0 pressure right now. And I'm just going to get a little Allen key. I've got to tap into the gas valve so that I can check our pressure. Every gas valve has 2 ports on it. The port closest to our manifold here is going to allow us to check manifold pressure. If we look down here, we've got another port. That one allows us to check street pressure. So on a maintenance, I'm concerned about manifold pressure. I want to know what that's doing before I check anything else. So I'm going to hook this little hose up to my device here. This is going to let me check his gas pressure. So we'll put that like so. And filters. So these are important. I'm going to give you guys a quick rundown on filters. So in this case, filters put in the right way. If we look, there's always arrows on the trim. The arrows got to point to the furnace. We've got chicken wire, extra reinforcement on this side so it doesn't get pulled in the blower motor in case the glue unsticks from that filter material. I've seen many times where the filter's in backwards. No chicken wire here. That material gets sucked in. Within 3 seconds, it'll take out the control board and the blower motor in one shot. These control boards could be $1,000. Those blower motors could be $1,000. They're very expensive. Now this blower motor, he's only got an AC motor. It's a builder model high efficiency, meaning it's alternating current. The DC motors, the real energy efficient ones, DC motors are about $800–900, could be $1,000. This motor is probably going to be about 400. So now I confirmed his filter's in good condition. It's in the right way. I've got all my instruments hooked up. I've cleaned the burners. I cleaned the flame sensor. Once I get this furnace running, I'm going to be observing my number here. I want to check the pressures, as well as I'll be doing a carbon monoxide test in this pipe, making sure that it's under 200 parts per million. Most of our furnaces, we only get a threshold of 100 parts, but this particular Amana unit, we can go all the way to 200 on one. And I'll give a quick explanation what I'm looking for. So up here we've got a maximum unit amp draw of 10.3. We've got some temperature differences, so 25 to 55, this is called our temperature rise. That's the number we want to see the difference in between our supply air temperature reading as well as the returning air. So I will put a couple thermometers in the ductwork and we'll confirm that we're getting that number where it should be. If we go down here, we've got manifold pressure 3.5. Low pressure is not applicable. So again, this is a high heat only furnace. If we had a two-stage furnace, meaning it had low heat mode and high heat mode, there would be a value in this part here. So with this furnace, when I start it up, I want to make sure my number is not over 3.5. Other than that, that's about all I need to know. If we go up to the serial number, 22 represents the year of manufacture, and the 03, that's going to represent the week of manufacture or the month. I'm not 100% on that, but I definitely know that 22 is year of manufacture. So his furnace was built in 2022. And today we're 2023. So it's been around in existence for a year. So whenever we're playing with doors, we get some sharp edges. We want to wear our cut-proof gloves. I've got the safety glasses on. And whenever people are firing up furnaces, you don't want to be right up close to the unit in case there's a problem with the internal metal. I don't want the flame coming shooting at me and my face is right there. So I always stand back a bit or off to the side. Oh, one thing I want to point out to you guys too. So when we take a bottom door off, we've got a door switch here. That door switch opens, taking the power away. Now I noticed this one, see how the light's still flashing there? Our door switch isn't opening. So we've got some dust in there. I'm going to try to free that up. A burner brush to see if I can get some of that stuff out. I don't know where I put that guy. There it is. Yeah, so this little bit of dust and stuff gets in here as the door opens and closes, and then that can prevent it from opening all the way. If a kid takes this door off, or somebody that doesn't know what they're doing, they want power disrupted in case somebody reaches in there. If that blower's spinning, you're going to lose some fingers down there. So what I'm going to do is put his door back on, and we're going to start getting the maintenance going and get some numbers on his furnace. So we'll close this. Way to check our power consumption is we're going to go to the white wire, which is the neutral on our main power box here. And I'm going to hook my amp meter around there. Now when his furnace starts up, we're going to start seeing these numbers go up. It's just the power consumption that the furnace is using. The higher the number, the more power that we use. So we'll give that a minute. This will start up in a few minutes. In the meantime, I'm just going to get my temperature probes. I got my thermometer. Right now 69.4. I want to put this in our ductwork. I want to see what our supply temperature is, as well as our returning air temperature. So we'll start with our supply, and we've got to find a spot to put this. So very good area is going to be a duct cleaning plug. Duct cleaning should be done in the home every 5 years. If you have pets or you smoke in the house, you might want to do that service every 3 years. It keeps your filters from plugging up early, and it cuts your hydro costs down quite a bit. Now if we look over at my manometer here, we've got a maximum threshold of 3.5 inches of water column. This meter's reading 3.78. So I'm going to remove this brass cap, depending, they didn't do it up too tight, and then he cranked this right on and we go to take it off and it wrecks the screw head. So if that happens, I cannot adjust it. So I'm going to do my thing to try to get that number down to 3.5. So with these, I find the easiest way to try to get this screw out without wrecking it, I'm going to go tighten it first, just a little hair. So I felt it move, now it'll back off. So that way I can get that screw out without stripping it. If I were to just turn it to the left, it would have took a chunk of brass out and this cap would have been in place till we got a new belt put in. So to adjust our gas pressure, I'm going to go counterclockwise. So if you look, our number's slowly going down. And why it's important to have the gas pressure set properly. If my gas pressure is too low, I'm not going to get good heat in the home. And if it's too high, it's going to create too much heat, which could cause our furnace to do what they call a short cycle. So when that happens, the furnace overheats, our burners turn off, goes off on a high limit safety, and then our blower runs for about 5, sometimes 10 minutes trying to cool down that metal before it'll start back up. If your furnace is short cycling, it's going to repeat this process day, all night. And at the end of the month, when you get your hydro bill, expect to see a very high cost. Because the house isn't heating good, furnace isn't working properly due to it overheating. So I've just got to try to get this little cap back in place. This is just a dust cap. It keeps the dust from going into where we have to adjust the valve. These things, you don't want to crank them tight. Just snug, that way if they ever need adjustment, we can take that out without wrecking it. So gas pressure, I'm just going to tear this back to 0. So give me 1 minute. So I'm pinching the line so that I'm not releasing gas. I'm not at 0 yet, so I'm just going to keep bringing this down, calibrate it till I hit 0. Okay, so now my pressure is going to be accurate on the measurement I'm getting. So 3.52. So the next step I'm going to do is a carbon monoxide test in this exhaust stream. 200 parts per million. I don't want to see over that number. Being a 1-year-old furnace, I don't think we're going to get close to that. So we've got a fresh air purge of 53 seconds. Once we get down to 0, I will hook up a hose to this probe here, to this nipple sticking out. There's a little rubber plug here. I can check CO here. Whenever I do a CO check, I get the highest reading right at the port here. So we'll let this count down. Now, as for our electrical amp draw, if you look at our screen here, we've got it was going 5.5, it's now 4.76. So this is the amp draw on our venter motor running, as well as our blower motor that moves the air through the house. If I had a reading over that sticker number, my eyebrows would be lifting up, because I predict that one of these motors are going to burn out soon. So I'm happy with the way the electrical test is here, as well as the operation of these motors. So now we're going to do that carbon monoxide test. So I've got 0 CO, and I'm going to hook up my little probe here. So I'll do this up here. I've just got to get a pair of pliers just to remove this little plug from here. Okay, so we'll just put that down. And now we'll start running this carbon monoxide test. So if we look at our meter with this furnace, we can go up to 200 parts per million. And our meter is reading 72, 73. So that's a pass. If I were to have a reading over 200, I'd be making sure my gas pressure set correctly, making sure our burners are clean, no spider webs in the orifices. If we get spiders in here, I've seen that number be at about 4,000 parts. the condensate hoses are containing water and not allowing the water to drain. That number could be 400 parts per million. So at maintenance, we're going to keep our CO numbers as low as we can get them. It's sitting at a 71 right now, but on a maintenance, I always document my highest reading, which the highest number I seen today was 73. So I'll just leave that there for a minute. I want to see what my temperatures are doing. So if we look over here, I've got a supply air temperature of 121. And now we've got to take a return air measurement. So I'm going to go right back in here with the return. There's a little duct cleaning plug. So that's going to take a bit for our temperatures to come down. So we'll let that stabilize. In the meantime, we'll double check that CO number. So 74 parts. It went up 1 part, 2 parts. So I'm going to put us here at 75 parts per million. So you want to take the tube out. Always make sure you're putting your rubber plug back in, because condensation is going to drip from here. And it is a very tight fit on that fitting there. The returning air, it's coming in at 77. A 2-stage furnace. So if I'm in low heat mode and I look at my meter, I'm lucky to hit a 2. That's with our venter going in our blower. The blower runs a lot slower in low heat mode, why it uses less power. When we get in a high heat only furnace, it creates a lot of heat, so that fan has to run a lot quicker than a low heat mode furnace. I'm gonna stop operation of this furnace by taking that door off. Just before I do that, I want to test out his pressure switch safety. So this safety is incorporated with the venting system, so that if a bird flies in the vent or if snow plugs up against it, they don't want these fumes coming back in the house, because there's products of combustion, being carbon monoxide in there. So I'm going to pinch this hose. Burner's turned off. That confirms our pressure switch is operating properly. I duplicated that vent being plugged, so once it gets plugged, I want the switch opening, killing the power to the furnace. So we're going to give it a minute. This thing's going to try to start back up. It'll make sure that pressure switch is closed. If this switch isn't closed, we're not going to have the burners ignite. So because I did test the safety, I want to make sure it didn't fail in the process and that it is still working. So we'll just wait a second. Okay, so burners are on. I usually count 4 seconds just to make sure we're satisfying the flame sensor, and our pressure switch is remaining closed, which will give him great heat in his house. So now I'm finished with the maintenance. I've got to put everything back together, and I've got to do a leak test at this valve because I did tap into it. I don't want to be leaking fuel. So I'll take this door off. And furnace switch killed the power to the furnace, as it should. So what I want to do now is I'm going to get my Allen keys, and I just want to check both ports for his valve. So I'm going to double check the street pressure one, turn it right to tighten it, left is to loosen, and then up here this one is loose because I just checked gas pressure. Very important that these things get tightened up. You want to soap test them, make sure nothing's leaking. And then what I'll do is just a quick leak test once the burner is light on that port I've tapped into. As for the other port, sorry about getting in front of the camera there, I can soap this one up now. So this one's street pressure, which this little fitting's got gas going through it. So if I was leaking gas, it's going to blow up bubbles. And then just give me an indication to tighten it more to get that leak to stop. So as you guys can see, none of these bubbles are moving. I've got nothing blowing up, which indicates that there's no leak at that port. Now what I'm going to do, you always want to dry up the soap, because if you don't, you're going to get a lot of calcium and stuff building up along that valve. and then that could mess up the little washer that's in there. So last but not least, on all my furnace maintenances, I always like to wipe down the furnace before I put the doors on, because we do get a lot of dust accumulating everywhere over time. So I'm going to wipe his manifold, just make sure the gas valve's good, checking down here for any leaks. Gaskets at the back leak a lot, so I want to make sure I'm not seeing any visible signs of that. As for the doors, I'll wipe them down and then I'll put his furnace door back on. And I've got to do a leak test at that port I've tapped into to check his gas pressure, just to make sure I don't leave him with a leak. So we clean the door, wipe the outside, the inside down, get all the dust off. And we'll put this back on, we'll fire up the furnace, and we'll run a leak test at the valve. So I can start putting all my tools away, because there's nothing else I have to do except for my leak test and put the top door on. So your furnace passed with flying colors. It's doing a great job heating, and the most important to us gas fitters is it's operating safely and keeping the customers safe. So yeah, in a couple minutes this will start up, and then I'll just soap up that fitting. And we'll go upstairs and turn your heat down. You might see, if you're at your house, you might have one pipe going outside, and then you'll have a little stubby pipe here with a fitting on it. That means they're drawing the air from your furnace room. They're not taking it from outside. If it was up to me, I'd like to see a 2-pipe system on everything, because when they're drawing air from a furnace room, we're taking his energy, sending it through the heat exchanger, and it's going right outside. There's that saying, we don't heat the outdoors. Well, in the case that we're taking the air from the furnace room, we got heat going to the outside from the house. So hence why I don't like 1-pipe system. I always want to see 2. So we've got our burners lit, nice blue flames there. I'm going to soak up the fitting, and we got to see if there's any leaks here. So again, if we had a leak, it would be literally blowing up bubbles. So what I'm going to do, I'm going to just replicate what a leak looks like. And that way you guys can see how we get indication on the leak if we're at a fault. So I'm just going to back this off just a sliver. So if I were to soak this, right now this is leaking. You can actually see that bubble there. That indicates we've got a gas leak. So in order to stop that leak, I'm just going to turn to the right, make sure I tighten it. And what I'll do is I'll just supply a little bit more soap on there, just to make sure that it is not leaking. As you guys can see, we've got no bubbles. Those bubbles aren't blowing up anymore. That port's closed and no leaks. So last thing I want to do, again, we want to take that soap out of there, because we're going to get white stuff building around that little port, and that could cause a little leak in the future. So we'll just make sure none of that stuff's there. And then I'll wipe this door down, and we've just got to go upstairs and turn your heat down now. I recommend a gas furnace get inspected every year. I've heard of manufacturers voiding warranties if the customer can't produce maintenance records at least every other year. So if you do have that factory warranty on it, make sure you're getting it looked at. Maybe even ask the manufacturer how often a maintenance should be done, so that your warranty stays good.